Hi, my name is Tejas. That's pronounced like contagious disease. I am not contagious, at least at the last checkup. But it's just a way to help you pronounce my name. And I have worked at a ton of different tech companies over the years. I've been writing code a very long time. In some capacity, I've been on the team. In some capacity, I've done consulting, et cetera, for some of these folks. And it's been an absolute honor and a privilege. Today, I lead a developer relations consultancy. That's a DevRel consultant, a small agency. We help companies do DevRel. If you're interested in DevRel, I'm here. I'd love to talk to you about it. But that's not what we're here to talk about today, okay? Today, we're here to talk about front trends. That's trends in the front end. I did my best. I'm not a marketing person. But trends in the front end world. You may have heard things about signals, reactivity, bun, tailwind, HTMX. What's going on? And the reason I'm giving this talk is because my suspicion is many of you, even like me, sometimes we're at work. We're just doing engineering. We're probably in the stack that we work in. So we're doing, React all day. We're doing some server-side stuff, and we hear things like Bun and Astro and we go, okay, that's cool. I want to dive into that, but I work, and then ideally I have a life, and I don't want to spend my weekends diving into this stuff, right? So the motivation here is that in 30 minutes, we bring you up to speed. We give you some information, some context around this, such that you can have high-quality conversations with your peers about more details and really have a deeper understanding of these things. Okay, that's the hope. One caveat is probably already outdated. I joke that I did my best to keep it as up-to-date as possible, even up to this morning, but as we know, the industry moves very, very fast, and some things may be out of sync. To the best of my ability, not, but we'll see how we go. We may not have time to finish. It's a lot of topics, and so if you want the long version, I'd encourage you to come follow me on socials, X, YouTube, etc. With that, let's get into front trends. What I want to do is I want to highlight three trends that we see front-end engineering, web engineering moving toward in the recent months, okay? These three trends are adjectives about what's happening to front-end. Let's get straight into it. The first one is it's blurry. It's blurry. What does that mean? It's blurry. Well, when many of us started, there was not like front-end engineers, back-end engineers, prompt engineers. There was what? There was webmaster. There was, I make the website. What do you mean you make the website? I make the website. I'm the webmaster at something.com. I drag and drop things over FTP and I upload the website and it's good, right? And then we got more specialized. Things like front end became a prevalent topic, things like back end. These specializations emerged. And there was this clear distinction between front end and back end. So with the front end, you work on the user interface, you respond to events, and sometimes you network with some API that you're not responsible for. The front end these days is more blurry because we see the rise of one particular component in the stack, the best friend for the back end for the front end. And this is way more common. You have a lot of front end engineers who are now writing back end-ish code kind of between the real back end and the back end for the front end, doing things like middleware, doing things like server-side rendering, et cetera. This is a huge thing. And what it's doing to the front-end specialization is it's blurring it a little bit and enabling more people to be full-stack engineers. And that's tremendous. There's a number of benefits to having a BFF. Number one, data fetching. Data fetching becomes faster because when you have a backend for the front-end service that you deploy close to a database geographically, the round-trip time to interface with some other storage mechanisms is drastically reduced. It is more secure, because you have secure backend services talking to each other. The most common mistake, listen, we do consulting, and we see an extremely common mistake where people will fetch data from some backend service from the browser. They will literally include tokens in a fetch request that you can then inspect. This is very, very common, and when you have something like the BFF, you're not at risk of that, ideally, because what happens is you fetch secure tokens on your backend for the front-end server-side stuff, and then you just, the front end is a bit naive in this way. So it's secure, it's faster. Data fetching is a huge benefit with the BFF. Number two, rendering. When we render things on the server side, a couple of things happen. One, we can render. So what we mean by rendering is taking a tree of elements, either React, Svelte, Solid, whatever you want, and turning that into something the browser can understand, usually a string or a stream of HTML. Okay? So rendering, when we do it on the client's device, it's a CPU-bound operation. And that happens on devices that we can't control. We don't know how much RAM our users are using. We don't know what constraints they have. We do control the constraints of our own servers, our own BFFs. So when we render on the server, we can choose the right performance constraints. We can also render parts on the server and parts on the client, so we have more control. Server rendering also ships actual markup to the user instead of just some script tag to download JavaScript and nothing else. Third, the benefit of BFFs are you can deploy all of this stuff to the edge. What does that mean? You just put it really close to your users geographically so that it's faster. The internet is bound by distance over the earth. And the closer something is to your users, the faster things are going to be in some, not all cases. But these are tremendous benefits of the BFF that's available to everyone today, and that's why front-end has become a little bit blurry, because we're all kind of writing a little bit of back-end code. The prevalent advice in light of the BFF is to just use a framework. So if you're building a React app, just use Next.js. Just use Remix. If you're building a Svelte app, just use SvelteKit. If you're building a Solid app, just use Solid Start. The core team of React, Andrew Clark at Vercel, says if you use React, you should be using a React framework. If your existing app doesn't use a framework, you should incrementally migrate to one. If you're creating a new React project, you should use a framework from the beginning. Okay? I hear this, and I ask why. And the answer to this question is the BFF. It's those benefits that you get. And if you don't use a framework, what will end up happening, what happens a lot, is you will actually create your own framework, but it won't be as good, because it's not maintained by the world. And the issues you fix will have been fixed already, okay? But I've been doing a lot of talking. Let's actually show you the value of the BFF and its blurry nature. To do that, we'll switch to the laptop right here. And what we should see, I asked him to mirror my display, and he didn't. So let me do that. Let me just mirror my display. How do I do that? Is it advanced? Gosh, the Mac OS is... Oh, here we go. Use as, mirror, boom. Yes, awesome, okay. So what we have is an empty browser window, and what we're going to do is actually implement a BFF. So we'll bring that to the side, we'll open VS Code, and let's just get started here. So I'll zoom in a little bit. So what we have is a client-rendered only application, okay? So if we cd into framework, and we npx vite, what we're going to do is we're going to run this project, localhost 5173. We have a project that loads a bunch of dog breeds from an API, and it shows you a list. So this list comes from an API. It's got some network I/O, some data fetching, and you can click things you like, and the UI updates. So this is a representative of a very basic application, but it's entirely client-rendered. And the problem of that is if you don't support JavaScript, if your browser doesn't support JavaScript, this is what you see in the source code. A script tag. If you're a search engine crawler and you don't speak JavaScript, this is what you're sending to search engines. It's just not ideal. To fix that, we need a BFF. We need something to render the stuff on the server and then send it over the network. We're going to create a basic BFF live right here, okay? Just to show you the value. So we'll make a new file. We'll call it server.tsx, okay? What do we need to render this on the server? Well, first of all, we need React. This is a React app. We need some way to render it to a string. And so we'll just import that from React DOM server. We need some type of server. So we need Express. So we'll do something like this. And then we'll just create a simple Express app. So we'll do this. Express, by the way, is the way to do servers in Node.js, if you're not familiar. We'll do app.use, and we'll include the dist directory. And we'll listen on the / route. We get the request and the response. And here what we're going to do is just res.end, and we'll send the string. But instead of hello world, we'll send our application, okay? App, like this. And finally, we'll app.listen on 3000. And when we're listening, we'll just be like, console log, yeah, cool. That's it. We've created a really basic BFF. Let's run this and see what happens. Now, how we're going to run this is using another new trendy thing called bun. Bun is a replacement for Node.js. It's faster, it's better in many ways, but bun is useful here because notice, we're using TypeScript first of all, we're using JSX, we're using a bunch of things that Node.js has no support for out of the box. Bun does have support for this out of the box, okay? So what we'll do is we'll do bun server.tsx. By the way, one note, we're using Express. Bun has a built-in global server. We don't actually have to use Express with bun. I'm just doing it because I'm used to it, okay? So let's run this. Server is running. You see that was instant. And we'll go to localhost 3000. And we get this. And that's because we didn't set a content type. So we'll do res.setHeader. Exactly. Thank you, Copilot. We'll tell the browser we're sending HTML, kill the server, restart it, and now we have this. The problem is, and by the way, the markup we're sending now is not a script tag. It's actually text. So search engines like this. Okay. The problem is, we're not doing data fetching. And it's kind of sad, because we're not sending the full picture to the user. So they're going to download JavaScript, fetch again. It's not efficient. We're doing network waterfalls here. We can do better. We can fetch data on the server side. The way we do it nowadays with frameworks, specifically even in React 18, is we don't do much. What we do is we just change render to string to render to pipeable stream. That's really it. It's server.node. I'm just telling Bun that's server.node. And we change this just a little bit. So instead of render to string, what we'll do is we get a pipe function from render to pipeable stream. So we'll just do this. Okay? We can give it some options. So we can say on shell ready. That's when the app shell is ready. Then when the app is ready, we'll set the header. We'll actually set the header here. And we'll pipe this to our response. We'll pipe our HTML. So what we're doing is we're streaming. We're not sending a string, but we're asynchronously rendering React on the server. And when it's ready, we stream that over the network when it's ready. When React encounters a place where it needs to fetch data, it will pause the stream. It will fetch data. It will come back and update the UI, all from the server side, from the BFF. This is why it's valuable. So I'll save this. I will save this, and I'll restart my server. Server is running. That's so fast, I can't get over it. Now, I want you to pay attention to this, because there's no JavaScript on this page at all. There's no React on this page. So if we look at the React dev tools, you should see up here, it says this page doesn't appear to be using React. This is entirely server. There is no client JavaScript at all. If I reload this, I have data. How is that possible? How am I data fetching? Let's kill the server. Let's try it again. It fetches data. That's kind of nuts. And the reason it fetches data is because we're using newer React primitives. We're using render to pipeable stream. And in the source code, if we look at app, we're using suspense to fetch data with these resources. There's a new use hook in React. This gets too much into React. We don't need to talk about React. This is not about React. But this is about the BFF. We're doing all of this without, you can tell there's no JavaScript on the client side, because if I click on a checkbox, indeed, this number doesn't update. So this is not responding to state because there's no React at all. I can fix that on the server side by just adding bootstrap scripts. So there's another option, bootstrap scripts. And I can say something like /client.js. And this will load JavaScript on the client side as well. And then everything's fine. But the real goal, the idea is we can do a lot on the server side. And by doing it on the server side, look at what we're sending to the client side. We're sending a big list of dogs. So all the names are there. Affenpinscher, African, which is a breed of dog, Airedale, et cetera, et cetera. So we're sending meaningful syntax instead of just script tags. That's the value of the BFF. The next thing the front end is trending towards is to be more fine-tuned. We care a lot about performance, and we should, because according to web.dev, which is the leading resource on web development, they have an article called Milliseconds Make Millions. And this is where, honestly, a lot of people think, why should I care about performance? Because it makes you money. And if it doesn't make you money, it makes people happy. Okay? I go to buy tickets for Ryanair, and I click buy, and I wait 30 seconds, and I'm like, wow, 30 seconds. I wait 30 seconds to give them money they don't deserve. Anyway, when things are fast, we're happy. The virtual DOM was the thing that made React and Vue very, very popular. But it's been recognized recently as slow and inefficient. And I'm here to tell you it is not the fastest way to do update detection and update management for UI state. The reason for this is because it requires 2 copies of the DOM. You have the DOM, you copy the DOM, you update the copy of the DOM, and then you commit that to the actual DOM. All of that is not as efficient as an alternative. The alternative is reactive data types, reactive primitives, reactive values, and reactive functions. What I'm talking about used to be called observables in Knockout.js, is now called signals. You may have heard. Have you heard of signals? Who's using signals in production? Yeah, no one. Wow, this talk fits. So, signals. Why are they better? Instead of telling you, let me just show you. I will show you a side-by-side of signals and VDOM, okay? Let's bring this browser to the full screen, and what we're going to do is cd to another directory. We'll cd to bundle size react, and we'll npm run dev. And in another tab, we'll cd to reactivity, npm run dev. I should maybe go here and change the port. Perfect. Okay. So one is going to be a React app with VDOM. Another is going to be a solid app with signals. And I want to show you the differences. So we'll do localhost 3000. This will be the React app. And we'll do localhost 3001. And we'll load them in a split screen. They're both counters. Surprise. And you can already see the React app. Okay, let's look at VDOM versus signals. So with virtual DOM, I'm going to increment my counter. And what you'll see is everything else increments. It's not supposed to. Whereas with signals, nothing else increments. And you might be thinking, okay, well, tell me more. Well, let's look at the code. So what we're going to do is go to the editor here. And we'll go check out the code for those. So I'm just going to go to the React code. And the solid code is literally the same. So if we look at the React code, what we see is we have a home component, div, a counter, a button that increments the counter, and a component. What is component? Component is a 10,000 element array of random numbers. Okay? And that's kind of what you see here. In both cases, solid syntax looks exactly like React, so there's nothing different here. The difference is reactivity. Listen to this carefully and maybe tweet it if you want. React is not reactive. React is, and this is what I mean by that. Reactivity means you have a value, and then something subscribes to that value, and when that value changes, it notifies the subscribers. That is the reactivity model. React is not that. Here's how React works. When I click increment, let's make this side by side. Cool. When I click increment, what's happening is it's calling this function setCount that then calls home, then calls component, that then calls math.random again. So it's calling a bunch of functions every time I change state. That's React. That is not reactive. That's just function composition. Okay? What is reactivity? Let's look at the solid side. So if we go to the reactivity directory, source, routes, index. So what you'll notice right off the bat is that the source code looks exactly the same. Home, counter, set counter, etc. The only difference is that we read state as a function, and we set state very similar. But this is the secret sauce. This function does a bunch of things under the hood. When you call this function, it implicitly subscribes the component to this observable value. And then when we update it, the reactive value notifies the subscribed component. What I'm trying to say is home, this function is never called ever again, ever. It's called once, that's it. This value is the one that changes. Therefore, we have fine-grained reactivity. This is the whole appeal of signals. It's just faster because it doesn't re-render your entire app. But how do we make React behave like solid? We can solve this problem pretty easily by wrapping this in memo. That's it. And as long as the props don't change, we're good. I can literally look, it behaves exactly the same. The counter is incrementing, but nothing else is changing, right? But the problem is there's friction. With React, you have to think about this stuff. Oh, do I need memo? Do I not need memo? Am I going to run into stale state, etc.? With signals, you just kind of get it. The React team is doing work to create a compiler for you that will automatically add memo like where it should without you thinking about it. This compiler is called React Forget. It's a work in progress, and it's coming, but you maybe don't need it. It depends. It really depends. There's an excellent article by Daishi Kato called Why You Don't Need Signals in React that goes into more detail about this. We don't have time, unfortunately. I have like 10 minutes left. But I'd encourage you to have a read of that if you're interested in this type of stuff. All right. We're nearly done. The final thing that the front end is trending towards is it's trending towards being invisible. It's disappearing. It's no more front end anymore. And the reason for this is we ship a lot of JavaScript. Bundles are like megabytes and megabytes and megabytes. And it sucks. Like it makes the experiences heavy and slow, especially on low power devices. So in the name of performance and accessibility, the preference is to just ship like no JavaScript. What does that even mean? Let's do a demo and show you. So what I want to show you is a project called Quick. Anyone heard of Quick? Anyone using Quick in production? Anyone familiar with how Quick works? Awesome. Okay, one guy. Awesome. I'll just show you. So again, we have a counter implemented in Quick. Quick also has support for signals, but let's go use Quick. So let's kill this, and if we come here, we go to quick npm run dev, okay? And we'll go to now localhost 5173. This is quick, and it's a counter, and as you can tell, wow, it's a counter, fantastic. There's magic happening here that you're not seeing, but is tremendous. The source code of this is, as you can imagine, it's just a counter. But what I want to show you is the network tab. Let's bring this panel down here, and let's zoom in, because you're about to see some absolute magic, okay? So what we're looking at is first load JavaScript. And what you'll see is there's typically almost no first load JavaScript except this. What we're seeing here is this route, because it's on the viewport. When I click increment, I want you to watch the network tab, okay? Increment. Oof! A lot of stuff loaded. I got carried away. And what loaded? So if we look at what loaded, there's this file. Okay, there we go. There's this file that loaded with the name. It's called routes component div button onclick gurahajale app8.js. What it's doing is it's loading the onclick handler on demand. When I go to click the button, then it loads the JavaScript. By default, it loads absolutely nothing. You might be asking what the code looks like, so let's take a quick look. So we'll go back to bundle size quick, and we'll look at the code here. And what we'll see is the code looks kind of like you'd imagine. They stayed very close to React. And what you see is component dollar, use signal, onclick dollar. This dollar sign tells the quick optimizer any function inside the closure of the dollar sign, take that out, separate into a separate module, and then lazy load it only when it's needed. Okay? So what's with the dollar sign? The onclick is dollar signed, but also the entire component is dollar signed. The component will only load when it enters the viewport. If somebody doesn't visit this page, they never download the JavaScript for this page. If somebody doesn't click this button, they never download the JavaScript for this button. And so quick loads on first load a constant size of JavaScript. It is not variable. It's not O of n. It's O of 1. You load 1 kilobyte of JavaScript always on first load. It's predictable. And then when a user goes to do something interactive, then it loads more progressively. It's progressively enhanced. The result, you always ship 1 kilobyte or less of first load JavaScript, always. Currently, in our applications, we ship event handlers that are never used. Megabytes of them. We ship on-click for things that people will never click on. We ship navigation events. We ship all kinds of stuff that people will never use. Quick disappears until you need it. And that makes it the fastest way to build front ends today. Okay? And I wanted you to know there's more details here. Of course, we don't have the time. I've got like 5 minutes left, but I did a video on this in a bit more detail. If you're interested, that's on YouTube. I'm not going to tell you to like and subscribe because I'm not an influencer, but like, I'd appreciate it. Let's wrap up. There's a lot of UI tools around, and I wanted to give you a quick update on all of them. I'm not an authority, by the way. I didn't write these. I just listen to people. Angular is tremendous. It is a library, it is a framework, not a library, meaning it's a Swiss Army knife. It has support for routing. It has opinions about a number of things, and it's great for enterprise applications. Okay? Angular is undergoing significant changes, and they are adopting signals. Why? Because signals are faster and better, period. They currently use Zone.js for change detection, but they're moving to signals as well. Vue, similar, moving to signals and has a compiler. It's also fast and good. The thing for Vue that bothers me is the syntax. I'm just used to JSX, and Vue has a different way. But Vue is awesome because it requires almost no build tooling. You can literally just drop a script tag and write Vue components. It's fantastic. React we've covered significantly, so we won't spend much time. It is slower than all the rest because of the virtual DOM. I'm going to get in trouble for saying that. I'd love to be proven wrong, but it is what it is. Svelte is a compiler. It doesn't produce, it's not a framework that does stuff. It takes your Svelte code and turns it into good JavaScript. It's really great, and that also disappears at runtime in a way. Solid is a compiler like Svelte, but also uses signals. So it's like Svelte plus, not really, but it gives you some performance benefits, and it pioneered signals and influenced all of the other tools in the ecosystem. It is a huge deal. Finally, we just discussed Quick. It's like Solid, but adds lazy loading on demand, and is the first and only predictable constant size of first load JavaScript. So you might be asking, how do I choose? How do I choose the right tool for the job? They're clapping for me. How do I choose the right tool for the job? And Evan Yu, the author of View, said something really great at a conference earlier this year. He said this is Evan presenting, literally on my, this is a presentation-ception. Evan said, let's celebrate diversity. He says, instead of one thing to rule it all, we could use multiple. You can use React in a side project, you can use Solid, whatever. You don't have to choose one, and it's important to know all of them. But here's another question. What if you didn't have to choose? What if you could use all of them in one? That's nuts, isn't it? Well, that's kind of the value proposition of Astro. There's a number of other things. Astro, by the way, in my opinion, is the way. Like if I was to choose something today, I would choose Astro. Come talk to me about it after, I'll tell you why. But Astro allows you, by embracing something called islands architecture, which is the ability to have multiple islands. So if your website is an ocean of static content, you have islands of interactive content, islands architecture, little islands. And these islands that are interactive, you could build them with whatever you want. You could have a Vue island, a Solid island, a React island, and Astro does the work of tying it all together and gives you a reactive app however you want. It's a really great tool. It's, in my opinion, the best developer experience we have in front-end today. They've got a great, probably the best CLI around. It is a fantastic tool. I would do a demo, but we maybe don't have time. Let's do it, whatever. I just want to show you their CLI. It's so good. If we go to, let's do npm create Astro. And look at this. So I'm going to npm install. Maybe it won't work, and then we'll just speed run. But look at this. It's talking to me. It has a little face. It's the best. And so you give it a name, right? And it asks you some questions, but it's the most stunning CLI. And anyway, all that, the developer experience is chef's kiss. I love Astro. I don't work at Astro. It's just it's an example of high quality developer experience work. Okay, with that, I need to wrap up. They're telling me to get off the stage. I have 2 minutes left. Let's talk about things we didn't cover. The landscape is dense. I touched on things that I believe are very important for you to know so that you can evaluate your choices and make good ones. But there's literally many things we didn't cover. There's a whole AI space with v0.dev that's happening. There's CSS, which is entering level 4. There's Tailwind, which is controversial, but extremely good. I will say that. There's ways to debug that are novel. There's native ways to build, to take web technology, combine them with Rust, and then build native and mobile apps like Towery. And finally, there's things like Partikit and Lib. All of these, again, emerging things and worth paying attention to. Unfortunately, there's 30 minutes, but if I had an hour, we would believe me, we'd go deep on these. Let's wrap up with some takeaways. What can we take away from this? What we can take away from this is the space moves fast. There's a lot to keep up with. But even if you don't keep up with anything, you're good, because ultimately it's about solving a problem. And you might be thinking, what if I make the wrong choice? It doesn't matter if you, well, it does matter if you make the wrong choice, but my hope here is to not tell you to use this tool or that tool or the other tool. My hope is to educate you enough to the point where when you're faced with the, I love that. It's not, doesn't interrupt us at all. My recommendation is, okay, cool. So my recommendation is the answer to everything is that it depends, okay? But ideally, we've covered enough content to give you enough nuance to make your own decisions and balance the pros and cons accordingly. With that, thank you so much for having me, Infobip Shift. It's a pleasure.